All right, so we're going to work through a couple of practice problems now from the 6.4 practice problems in your homework packet. I'm going to do number 3 and number 5 and walk you through the steps that I just explained to you in the previous video. So let's look at number 3. Our first step is to write the charges of each ion. So I need my periodic table, which I have here. If I look on the front, I can find the charge for magnesium and sodium. So I like to write these just up above here like this. Magnesium's +2 and sodium is +1. And then to find sulfate and OH, which is hydroxide, I need to look on the back in my polyatomic ions chart. So SO4 is -2 and hydroxide is -1. Okay, so now I can see all the pieces of the chemical formulas and think about how they're going to rearrange in this double replacement reaction. So remember that the positive and negative ions will switch partners. So magnesium is going to bond with hydroxide and sodium is going to bond with sulfate. When I write the products, my next step is to make sure I have the right chemical formulas with those ion charges adding up to 0. And then we'll go through balancing the equation and everything. It doesn't really matter which order you write the products, but when I write them, I'm going to leave a blank so that when I go to balance it, I have space to do that. And I'm going to leave some blank parentheses for the states of matter. So I'll just go ahead and write magnesium hydroxide first. So magnesium's +2 and hydroxide is -1. That means I need 2 hydroxide ions with this 1 magnesium ion. So I'll write it as Mg. Then OH needs to be in parentheses with a 2 on the outside. So that's showing me I have basically a +2 charge and then 2 -1 charges, just like we did with the little pieces of paper. So that's my correct chemical formula. You can also write these chemical formulas using that like crisscross method if you like this, and use those numbers as the subscripts. But as I've explained to you guys before, I don't love this method because I think it's better if you just understand why you're writing the formula the way you are. Anyway, that's the right formula for magnesium hydroxide. And then I'm going to leave parentheses for the state of matter, write a plus sign. And then for sodium sulfate, I need 2 sodiums with my 1 sulfate. And I'll leave parentheses there as well. Okay, we'll get to the states of matter in a second. Let's go ahead and balance this. So one way to balance an equation is to write out all of the pieces that you have, keeping your polyatomic ions together. So I have magnesium, sulfate, sodium, and hydroxide. I can just keep track of how many things I have on the left and the right. So on the left side, I have 1 magnesium, 1 sulfate. Remember that 4 is part of the sulfate formula. 1 sodium and 1 hydroxide. And then over here on the right side, I have 1 magnesium, 2 hydroxides, 2 sodiums, and 1 sulfate. So right off the bat, I can see that I need to change my subscripts, or I need to change my coefficient over here on the left side so that I have the right number of sodiums and hydroxides. So if I add a 2 here in front of sodium hydroxide on the left, that'll change these to 2, and then I will have the right number of everything. So now my equation is balanced just by adding that 2 coefficient. I'm going to add a 1 in front of each of these. You don't have to do that, but you can if it helps you. So one major mistake that people sometimes make with these double replacement reactions is that they try to balance it and write the chemical equations all at the same time, which usually makes the students will make mistakes with writing the chemical formulas for the products. So make sure you go through it just like I did this one, that you write the products over here and you have the correct chemical formulas for those before you try to balance it. Okay, so at this point, we have balanced our chemical equation and we have the right chemical formulas. So now what we need to do is look at our solubility chart to find out which of these products is aqueous and which one of them is solid. So if we look at magnesium hydroxide in our solubility chart, that's right here. It says insol, that means it's insoluble, so it is going to be a solid. It's a precipitate. And then sodium sulfate is right here. That is soluble, so that one will be aqueous. So this is a precipitation reaction. A reaction will happen. There are some weird examples where you might have both products being solid, and that's okay. But remember, if both products are soluble and both of them would be aqueous, then that's no reaction. Okay, so that one is all done. Let's try the next one down here, number 5. Right, I'm going to erase this just so I have some more space. All right, I'm going to go through my steps again. Lithium, based on my periodic table, +1. Bromine, -1. Now this you might not be super familiar with, but this is ammonium. That is a polyatomic cation. You can find it right there on the back of your periodic table, and it has a +1 charge. So NH4 +1, and this is nitrate. Nitrate is NO3 -1. So those are both on the back of the periodic table. Okay, so once I have all the charges of these things, I want to make sure I think about how they go together. So lithium goes with nitrate, ammonium goes with bromide. And so now I need to write my formulas. This one's a little bit easier than the one above because everything has either a +1 or a -1 charge. So I don't have to do too much work when it comes to writing the formulas. I just need 1 lithium with 1 nitrate ion, LiNO3, that's lithium nitrate. And then ammonium bromide will be NH4Br. Basically, we need 1 +1 charge and 1 -1 charge. So that's all good. Notice how I'm not writing the charges in these chemical formulas. That's another mistake sometimes people make. But the chemical formulas should never have charges in them. That's why I like to write it above, as I'm kind of thinking through it. Okay. So this equation is actually also balanced because if we go through that process of balancing it, we actually already have 1 ion of each kind on each side. We've got a lithium, lithium, bromide, bromide, etc. So we don't need to add any coefficients to this one. If you want to write 1s in those blanks, you can, but you do not have to. So those are the correct formulas for the products. Now let's check those solubilities. All right, lithium nitrate is right here. That is soluble. And ammonium, let's see, where's ammonium? Ammonium bromide right here, also soluble. Okay, so when you have 2 things that are soluble, that means that they would both be aqueous. And when you have a reaction like this, you have to write no reaction because everything was aqueous to begin with, and it's all aqueous now. So there was really no chemical change. Nothing in the test tube or the beaker is different than it was at the beginning. So technically there is no chemical reaction here. All right, so you guys should be ready at this point to work through the rest of the 6.4 practice problems. I'll have the key for you guys posted tomorrow. As part of this assignment today, you also will have a few Schoology quiz questions to do. So you can go back through this video if you need to, but you should, make sure you've written down these problems as examples and then get to work in your homework packet and continue on with the Schoology quiz for today.